Start. Hi, I am Deepa Joshi, done my Bachelor of Engineering from VTU, trains Teacher Education Foundation course, Sylvan Learning Center, Phoenix, Arizona. So today I'll be starting with the topic polynomials. So before starting with the topic polynomials, let's talk about like terms and unlike terms. So, as you already studied in your previous classes, what are like terms? What are unlike terms? So, like terms are the terms in which the variables are also same and the degrees are also same. And in case of unlike terms, even though the variables are same, the degrees are different. So, why we have to study this concept like terms and unlike terms? So, we have to study this because addition and subtraction is possible only if we know in the algebraic expressions is possible only if we know about like terms and unlike terms. So today let's start with the topic what? Polynomials. So how we describe polynomials? The degree of a x raised to n, if a is not equal to 0, the degree of a x raised to n is n. So the degree of a non-zero constant is 0. The constant 0 has no defined degree. So this is the definition of a polynomial. So you can ask me, ma'am, if a is not equal to 0, yes. If a is not equal to 0, then only it is a polynomial. Suppose if a is equal to 0, then we cannot form an equation. Okay. So 6x raised to 4 minus 3x cubed plus 2x minus 5 is a given polynomial. So 6, what is this 6 called? This 6 is called the coefficient of x with a degree of what? 4. And 3 is called a coefficient of degree x cube. And 2 is called the coefficient of degree x raised to 1. And 5 is a degree of non-zero constant, that is 0. So definition of a polynomial in X. A polynomial in X is an algebraic expression of the form an x raised to n plus an minus 1 x raised to n minus 1 an minus 2 x raised to n minus 2 and so on a1x plus a0 where an minus 1 an minus 2 and so on up to a1 and a0 are what? Real numbers. So what are real numbers? You already know that, right? It includes both what? Rational numbers as well as what? Irrational numbers. And an should not be equal to zeros. So I've already told you in the previous slide that is about the definition of a polynomial in which an should not be equal to 0, because if an is equal to 0, then we cannot form a polynomial. And n is a non-negative integer. So the polynomial of a degree n, an is the leading coefficient and a0 is the constant term. So the first term of a polynomial is called the leading coefficient and the last term is called what? A0, that is a constant term. Why it is called a constant term? Because it does not have any variables. Therefore, we call it as a constant term. So coming with an example, minus 9x cubed plus 13x cubed. So you all know that x cubed is with minus 9 and x cubed is 13, and I have already told you about the like terms. So since both of them are like terms, so minus 9 plus 13, you already studied about the algebraic operations, right? Minus plus, plus minus, plus into minus, minus into minus. These 4 algebraic operations you already studied about. So minus 9 plus 13 taken in a bracket, x cube is common, which gives you what? 4x cube. Because minus 9 plus 13 is what? Plus 4x cube. The highest number bar, the sign of the highest number will be kept. That is 4x cube. These like terms both contain x to the third power, add the coefficients and keep the same variable factor, that is x cube. This is how we perform addition of a polynomial. So adding and subtracting polynomials. So combine like terms. So as I have taught you in the previous example, that is minus 9x cubed plus 13x cube, keeping the coefficient x cube common, that is x cube common, minus 9 plus 13 in bracket, so will give us what? 4x cube. So I have given an example here. Perform the indicated operations and simplify. So in the first bracket I have given you minus 6x cube plus 2x square minus 8 plus in other bracket 13x cube minus 4x square plus 4x plus 14. So before performing this simplification, I have already told you about the like terms. So keeping that in mind, you have to perform the operations. So minus 6x cube plus 13x cube. So these are what? Like terms. So minus 13 plus 6 will give us 7x cube plus 2x square minus 4x square. So these both are what? Like terms. So I have to perform an operation, whatever is required here. Plus 2 minus 4 will give us what? Minus 2x square. So here the coefficient of x is what? 4. But in the first bracket, the coefficient of x is what? 0. So 0 plus 4x will give us what? Plus 4x. Minus 8 plus 14 will give us what? Plus 6. Keep the greater number symbol, subtract because two different symbols. So I have given an example here. So please do it in the next class. If you have any doubt, I'll get back to you. Next, coming to the next part is about the multiplying polynomials. So in this minus 8x raised to 6, 5x cube I have given in the second bracket. So you can all ask me, ma'am, these are what? Unlike terms, because x raised to 6, x raised to 3, correct? But multiplication and division of unlike terms is possible. But like terms, in case of like terms, only addition and subtraction is possible. So minus 8 into 5 is what? Minus 40, because plus into minus will give us what? Minus 40. X raised to 6 plus 3 will give us what? X raised to 9. So how you got to know this? There are three laws of indices. So the first law of indices tells us that a raised to m into a raised to n will give us what? A raised to m plus n. The second law of indices tells that a raised to m divided by a raised to n will give us what? A raised to m minus n. The third law of indices tells us that a raised to m whole bracket n is equal to what? A raised to mn. So I use the first law of indices because x raised to m, x raised to n, there is a multiplication sign in between them. So I have carried what operation here? Addition operation. So x raised to 6 plus 3, that is x raised to 9. So now moving to the next part about multiplication of a monomial, that is polynomials. So multiplication of a monomial with a trinomial. So 3x raised to 4 whole bracket 2x cube minus 7x plus 3. This is an example. So first term we have to multiply with the first one. So 3 into 2 is what? 6. X raised to 4 into x raised to 3 is what? X raised to 7, because I have carried out the first law of indices here. So minus, because plus into minus is what? Minus. 3 into 7 is what? 21. X raised to 4 into x, there is nothing but x raised to 1 it is. X raised to 4 plus 1 is what? X raised to 5. 3 3s is what? 9. Plus into plus is plus. X raised to 4. Just have to keep x raised to 4 because nothing is there with 3. Okay. So next, coming to the next part is, I have given an example here. Find each product. So all of you please perform this example, and if you have any doubts, so I'll clarify in the next session. So multiplying polynomials, when neither is a monomial, multiplying each term of one polynomial by each term of other polynomial, then we have to combine the like terms. So I have given an example. X raised to 2 plus 4x plus 5 multiply with 2x plus 3. You already know the basics of multiplication, right? The first, we have to start from the left side. 3 into 5, 15. Plus 3 into 4 is what? 12x. Plus 3 into x square is what? 3x square. So in the units place, I have to keep it what? 0. 2 into 5 is what? 10x. Where is the x? So we have to keep the x term there itself. So it will be easier for us to combine the like terms. So 2 into 4 is what? 8x square. 2 into 1 is what? 2. X into x square is what? X cube. So now I have to add them. Plus 15 plus 0 is what? Plus 15. Plus 12x plus 10x will give us what? Plus 22x. Plus 3x square plus 8x square will give us what? Plus 11x square. Then 2x cube, just have to keep that 2x cube. So when I multiply with this trinomial with binomial, I'm getting what? 2x cube plus 11x square plus 22x plus 15. So you all know now, you understood what is monomial, binomial and trinomial when we are learning this chapter, what? Polynomials. So next I've given an example. Find each product. So there is a binomial in the first bracket, in the second bracket there is a trinomial. So you can perform this say the simplification and get back to me in the next class. If you have any doubts, I'll just come and clarify your doubts. The product of two binomials. So by using this FOIL. So what is this FOIL? So I'll explain you here. Multiplying two binomials using the distributive property. So 3x plus 2 in the first bracket, the second bracket it is 4x plus 5. So 3x plus 2 is what? Binomial. Even 4x plus 5 is a binomial because there are two terms. So first I have to keep 3x outside. Then I have to take the second bracket. What is that? 4x plus 5. We have to multiply along 3x. Then keep the symbol, that is plus 2. So plus 2 I have kept it. Then the second bracket, that is 4x plus 5, I have to keep it as it is. Now I have to perform the operations. 3 into 4 is what? 12. X into x is what? X square. Plus 3 into 5 is what? 15. X into 1 is what? X. 2 into 4 is what? 8. X just have to keep as it is because there is no x term or x related here. Plus 2 into 5 is what? 10. This is how I have to multiply two binomials using what? Distributive property. Distributive means I have to distribute the first bracket, that is 3x1 and 2 in another. So I have to multiply this, because since I am distributing 3x and 2, I have to multiply with the second bracket. Then I'll get an answer for that. So next coming, I have already told you in the previous thing, using the FOIL method to multiply binomials. So F means first, O means outside, I means inside, L means last. First, outside, inside, last method to multiply binomials. So the different methods to multiply binomials. Okay, you can use any of the methods for your convenience. Okay, so first means AX. The first of this second bracket also is what? CX. Product of first terms. Next is what? Product of outside terms. What is the outside terms? AX and D. Product of inside terms. What is the product of inside terms? B and CX. Next, product of last terms. What is that? B and D. So this is the operation which I can carry out when I can multiply what? Two binomials. So I have considered an example for you all here. So let's take 3x plus 2 in one bracket, 4x plus 5 another bracket. So what is the method I'm using here? FOIL. F-O-I-L. Product of first terms, product of outside terms, product of inside terms, product of last terms. So first terms, what is the first term? 3x and 4x is the first term. 3 into 4 is what? 12. X into x is x square. Outside. Outside is what? 3x into 5 is what? 15x. Next, inside terms. 2 into 4x is what? 8x. Next, last terms. 2 into 5 is what? 10. So, when I simplify these brackets, I get the answer as what? 12x square plus 23x plus 10. Next, coming to the example, find each product. Okay, so I've given you an homework and I've taken an assignment, and you can work it out on these two new sums. Next, coming to the multiplying the sum. and difference of two terms. So the product of sum and the difference of two terms. So I've talked to you about a binomial, correct? Multiplication of the binomial. So there are certain formulas, there is certain identities in algebra where I know the binomials of both the cases are same with respect to the irrespective of the signs. Suppose if it is a plus b here in first bracket, a minus b in second bracket, so the product of the sum and the difference of the same terms is the square of the first term minus the square of the second term. So a plus b into a minus b, that is completion of a brackets, will give us a square minus b square. So as I have told you, this is what? A binomial. So it need not necessarily you have to mug up this formula. This formula is useful in the further, like if you are going to solve the MCQs, multiple choice questions and all, right? So it will be helpful for you if you understand this formula. But it need not necessarily that you have to mug up with the formula, because as I have already taught you about the two methods, it is how to multiply the binomials just by removing the brackets, and how to multiply the binomials using FOIL method also. So you can use any one of the methods to find the product of the sum and the difference of the two terms. So given an example, 4y plus 3 in first bracket, in second bracket 4y minus 3. As you all know, 4y is the first term here and 4y is the first term here. In the first bracket, 3 is the plus 3 is in the first bracket, but minus 3 is in the second bracket. But you see the numbers are same here, right? So what I can do is, I can use the formula a square minus b square, because a plus b into a minus b is what? A square minus b square. When I square the first term, that is 4y whole square, I get what? 16y square, because 4 into 4 is what? 16. Y into y is what? 9. Y into y is y square. So it is what? 16y square. Now next term is what? 3. 3 square is what? 3 into 3 is what? 9. Square means what you have to do? You have to multiply a number 2 times. That will give a square of a number. So I've given example here. Find the product. 7x minus 4, 7x plus 4. So in this case, you can use all the three methods you can apply. I told you already how to simplify using the brackets, by using the FOIL method, by using what? Now identity which we have come across. That is a plus b into what? A minus b. So similarly, the two examples are there. Please just go home and solve them. The square of a binomial. So what is the square of the binomial? So the square of a binomial tells us that a plus b whole square is what? A square plus 2ab plus b square. That is, the square of a binomial sum is first term square plus 2 times the product of the terms plus last term square. So how do I come to this? That is a plus b whole square. You can ask me, ma'am, this is a direct, so I'm not able to remember the formula here. So what I have to do here, ma'am? So what you need to do is simply, if you don't remember the formula, what you can do is a plus b whole square. What is a plus b whole square means? Multiplying the binomial 2 times. That is a plus b into a plus b. Either by, I have told you the two methods, right? One is by the bracket or removal of brackets, another is FOIL method. You can use any one of those methods and you'll get the same answer. That is a plus b whole square as a square plus 2ab plus b square. So I've given an example here. X plus 4 whole square as what? First term square, that is x square. 2 times the product of the terms. 2 into x into 4 plus last term square. What is that last term? 4 square. So x square, I've kept x square plus 2 into 4 is what? 8. 8 into x is what? 8x. 4 square is what? Multiplying the same number twice. 4 into 4 is what? 16. So this is how I'll get the answer for that. Next is 2x minus 5 the whole square. So you all know that only I have taught you a plus b whole square here, right? So even we have one more formula, that is one more identity in algebra. That is a minus b whole square can be written as a square minus 2ab plus b square. I can use that formula and I can get the answer for that. So you all know that a plus b whole square is not equal to a square plus b square. Why it is not equal here? Because already we solve this a plus b whole square as what? A square plus b square plus 2ab. So in this case, you see, you are not able to see 2ab here, right? Therefore, a plus b whole square is not equal to a square plus b square. So all of you will tell x plus 3 whole square. Oh, exams, x square plus 9. Finished, I'm done with the sums. When ma'am will give some particular time limit, so what you will do, you'll quickly solve. You want to quickly get the answer for that. So what you'll do, you'll get x square plus 9. Oh, ma'am, we have got the answer. But that is wrong. Why? Because the middle term is missing here. What is that middle term missing here? So 2ab, right? So plus 2 into 3 is what? 6 into x is what? 6x. So that is the term missing here. Now, coming to the square of a binomial difference. So we have talked about in the previous slide about the binomial addition of the binomials. So square of a binomial addition. Here the square of the binomial difference, that is a minus b whole square, can be written as what? A square minus 2ab plus b square. That is the square of a binomial difference is first term square minus 2 times the product of the terms plus last term square. So I have given an example here, x minus 4 whole square. First term square is what? X square minus 2 into 4 into x plus last term square is what? 4 square. So it is x square minus 8x plus 16. So this is how we have to find the what? Products by using what? The difference of the binomials. Now there are special products. So what are the special products? That a and b represent real numbers, variables, or algebraic expressions. So special product, already I have discussed about this concept with you all, right? So a plus b into a minus b is equal to what? A square minus b square. So example I have given you here, 2x plus 3 into 2x minus 3 will give us what? 4x square minus 9. Squaring a binomial, that is a plus b whole square. Of course, I have discussed with you both the things. Squaring a binomial with addition, squaring a binomial with a difference. So when it is addition, it's what? A square plus 2ab plus b square. So example I have written is y plus 5 whole square is equal to y square plus 2 into y into 5 plus 5 square. That is y square plus 10y plus 25. Next is a minus b whole square is what? A square minus 2ab plus b square. So sorry, here it should be 3x minus 4 whole raised to square it is. Okay. So 3x square minus 2 into 3x into 4 plus 4 square will give us what? 9x square minus 24x plus 16. So we already have studied only about the special products, that is sum and difference of two terms, squaring a binomial. Now coming to the part that is cube. Cubing a binomial. So how do I cube a binomial? So I have to multiply a monomial 3 times. That is a plus b into a plus b into a plus b will give us what? A plus b whole cube. So what is the formula to find that, and how we get into that I'll explain you more detail when we'll come up to the cubing concept. Okay. So, but here I'm just giving you the identity. What is that identity tells us here is a plus b whole cube as a cube plus 3a square b plus 3ab square plus b cube. So x plus 4 whole cube, x cube plus 3x square into 4 plus 3x into 4 whole square plus 4 cube. So when I simplify that, I get x cube plus 3 4 is 12 x square, 3 into 4 square is 16, 16 3 is 48x plus 4 cube is what? 64. Next, coming to the concept is a minus b whole cube. So a cube minus 3a square b plus 3ab square minus b cube. So this formula I told you, right? You don't worry about this right now, because only I'm talking about just a simple product. That is only about the squaring polynomial, sum and differences in this particular chapter. I will be teaching only with those two things. So this one will get more in detail. See, you can ask me, ma'am, I'm not able to remember this. So I'll tell you a better way how to remember this if you are not able to remember the formulas here. Okay, x minus 2 whole cube can be written as what? X cube minus 3x square 2 plus 3x2 whole square minus 2 cube. When I simplify that, I get what? X cube minus 6x square plus 12x minus 8. So next, coming to the next topic, that is polynomials in several variables. A polynomial A polynomial in two variables, x and y, contains a sum of one or more monomials in the form of what? Ax raised to n, y raised to n. The constant a is the coefficient. I have told you, right? These are the variables. X and y are the variables. What is this a? You can ask me, ma'am, even though it is also, it looks a variable to me. But no, why it is not a variable? It's a coefficient. Why it's a coefficient? Because x raised to n, there is a degree associated with what? X. There is a degree associated with the y. Therefore, these are not said to be a constants here. So the exponents n and m represents what? Whole numbers. This is purely a whole number. We all know whole numbers include what starts from 0 to 1, 2, 3. It will not include negative numbers here. So if this is negative, then it cannot be a polynomial. So the degree of polynomial in two variables is the highest degree of all its terms. So you can ask me, how can we come to know about the degree of the terms? So I have given you the expression here. See, uh, 1 by 4 x square y minus 2xy, there is a second term, plus 4y. Okay, so the degree of this monomial is what? See, x to the power of what? 2. And y is associated with the degree of what? 1. So 2 plus 1 is equal to what? 3. See, second case. So this is also monomial, correct? So x is associated with the degree of 1 and y is associated with the degree of 1. So 1 plus 1 is equal to what? 2. Next, degree of monomial, that is y is associated with what? 1. And x, we do not have any x variable here. So x raised to is what? 0. So 0 plus 1, that is equal to 1. So these like terms both see the expression I've given you here, minus 7x y square plus 13x y square. Yes, we can add here. Why we can add? Because they both are what? Like terms. Because xy square, correct? And the degree is what? The degree of a monomial is what? 3 here, correct? You cannot write 1. No, wrong it is. Because the degree means you have to add the number of this one, the x associated with x, what is the degree? Associated with y, what is the degree? You have to add them. So that is the degree of your polynomial. So minus 7xy square plus 13xy square. So taking xy square outside the bracket, minus 7 plus 13 will give us what? 6xy square. So perform the indicated operations as I've given you the examples here. So you can all go back to home and just look into that. So coming to the next part is the quadratic formula. So what is a quadratic formula? What do you mean by quadratic? An equation. Okay, so with the highest degree of the x or highest degree of a variable is 2, then we call that as a given equation as a quadratic equation. And the associated, suppose let me write an equation ax square plus bx plus c equals to 0. See, for an equation I have written in the form of ax square plus bx plus c equal to 0. So you all see the highest degree of x is what? 2. So the condition for an equation to be a quadratic equation is where a should not be equal to 0. Then only I can tell the given equation is a quadratic equation. Or else, suppose if I write bx plus c equal to 0, is it a quadratic equation? No, because the x should be associated with the degree of order 2. Then only it is a quadratic equation. Can I tell ax square plus c equal to 0 is a quadratic equation? Yes, it is a quadratic equation. Why? Because the highest degree of an x is what? 2. So why we use this quadratic equation? We use this quadratic equation when we are not able to find the factors. When factoring is not an option, then we use this, we perform the quadratic equation. So to perform this quadratic equation, to factorize that, we should know the formula. What is that formula? That is Sridharacharya's formula. X is equal to what? Minus b plus or minus root of b square minus 4ac divided by 2a. If you substitute the values of a given equation in a, b, c, then I can get the what? The values for x. So this is how I perform the what? Quadratic equations. How to use the quadratic equations. So thank you. In the next class, we'll be discussing about the extension of the polynomials, that is the remainder factor theorem and the intermediate, the moderate problems of the polynomials. So thank you. So I've given you equation y is equal to x cube plus 5x square minus 9x. Sorry, let me complete this. So x is taking x as a common factor, x square plus 5x minus 9. So I've got a quadratic equation here. So because I've already discussed, see, when I give x cube plus 5x square minus 9x, no, it will not look like a quadratic equation. And why it is not a quadratic, it will not look like a quadratic equation, because I've told you only the highest degree of x should be 2. But since x cube is here, x square is here, x is here, in a given equation, I can take x common and make it in the form of x square plus 5x minus 9. So I have got in the form of what? Ax square plus bx plus c equals to 0. Now I can what? Factorize by using what? Quadratic equations.